Welcome back to lesson 16.2. In the previous lesson you learned what the Little Man Computer Simulator was. In this lesson we'll run a Little Man Computer program on paper. So in this lesson I'll remind you of the LMC instruction set and we'll look at the difference between the operator and the operand. We'll look at the mnemonic codes that are used in assembly language and we'll trace a program on paper. We looked at this list last lesson. It's the LMC instruction set. It's actually 10 instructions plus some storage locations will store data on their own. Sometimes students ask me how the computer can tell the difference between a number that represents an instruction and a number that represents data. Remember that in the von Neumann architecture, data and instructions are stored next to each other, and we therefore have to write our programs carefully so that the computer doesn't get instructions and data confused. They're both stored as numbers and they're stored next to each other in the same area of memory. Each one of those instructions is made of two parts, an operator and an operand. The operator is an instruction, it's a number that represents an action, followed by a number that represents an address. And I've represented those as XX because it can be any number from 0 to 99. The Little Man computer's got 100 numbered memory locations. So every instruction is made of an operator and an operand. So for example, an instruction might go 115. The number 1 stands for add and 15 stands for numbered memory location 15. So this instruction is saying to the computer, add the number at location 15 to the accumulator. Here's another example. 6 represents branch 2. It's telling the program counter to jump to a new memory location. And 02 means the instruction at location 02. So in the first instance, the memory location is storing a data value, and in the second example, the operand is pointing to another instruction. And each one of these machine code instructions can be represented in assembly language. In assembly language, the number codes are replaced by letter codes. We call these letter codes mnemonic. Look how mnemonic is spelled with a silent M. And that just means easy to remember, because it's easier to remember that the word add stands for adding rather than the number 1. But each one of these letter codes quickly converts into the number codes of the instruction set. So here are some examples. Machine code 115 is the same as assembly language add 15. Add the value at location 15 to the accumulator. 602 means branch to location 02. BRA stands for branch. 516 means load the value at location 16 into the accumulator, and 91 just represents take the input. And notice that that doesn't have a memory location. The input is just put straight into the accumulator. So you should have worked out, this was the exercise I left you with at the end of the last lesson, what each of these instruction codes stand for. So let's see what you should have done. You should have turned each one of those number code instructions into a mnemonic letter code, and that is the program written in assembly language rather than in machine code. So I'm now going to give you another activity, another task to do. Next to each one of those instructions, write a sentence saying what that instruction is telling the computer to do. If you're not sure, go back to that document I gave you with all the instruction codes on it, and it will tell you how to do this task. I'm going to ask you to pause the computer, pause the video now, go and write down this program and what each line of the program represents. So here's the meaning of each one of those lines. The first line says add the data from 04 to the accumulator, then add the data from location 5 to the accumulator, then store the contents of the accumulator back into location 4. That will overwrite what was there before. Then a command telling the computer to branch to location 6, so the program will jump over the next two memory locations, because those two memory locations represent data values rather than instructions. And then at location 6 is the instruction to stop the program. Did you get that? Okay, so that's the program that we're working with. Now we're going to trace it on paper to see what happens when we run the program. When we create a trace table to go with a Little Man Computer program, we have to have a column for the program counter and the accumulator, and for every numbered memory location that stores data. So PC, that's the program counter, the accumulator, and locations 4 and 5. At the start of the program counter is pointing to location 0, and locations 4 and 5 are storing the values 2 and 5. So let's go through this program now. The computer will fetch the instruction from memory location 0. That's the location that the program counter is pointing towards. So the computer will fetch and execute that instruction, and the instruction is add 04. So the computer adds the data value from location 4 to the accumulator. The accumulator had nothing in it, so it's now storing that data value 2. The program counter then counts on by 1. It's now pointing to location 1, and the computer will fetch and execute that instruction, and it says add the value at location 5 to the accumulator. So location 4 stays the same, location 5 stays the same, but the accumulator goes up by 5. The program counter now ticks on to location 2. At location 2, the command is store the accumulator back into location 4. So the accumulator is storing 7. We store that back to location 4, so it overwrites what was in location 4, and location 5 doesn't change. There's nothing to change location 5. The program counter now ticks on to memory location 3. Memory location 3 has the instruction branch to location 6. So that's a branch instruction. It doesn't change the values at any of the data locations, but it overwrites the program counter, which now ticks on to location 6. Basically, it's jumped over locations 4 and 5 because they're not instructions. And at location 6, the command is to halt the program. None of the memory locations change, and the program has finished. So that is how we go through a program in the LMC instruction set. What's the contents of the accumulator at the end of this program, and how would you amend the program so that it outputs this value? See if you can make those changes on paper now. So to recap, we looked again at the LMC instruction set, and we saw that every instruction consists of an operator and an operand. We can represent the operators using mnemonic codes, and that's what you'll be expected to remember for the exam. And I showed you how to trace a program by tracing the contents of the program counter, the accumulator, and every data location line by line as the program runs. So there's a workbook if you're one of my students. Workbook 1 has a series of programs to run using the trace table method that I've just shown you. In the next lesson, we'll run programs using the web-based simulator. Bye for now.